This video is going to be the first in our characteristics of the rigid transformations, and we're going to look at translations in this video. But before we do that, let's define what a rigid transformation is. A rigid transformation is a movement that preserves both the distance and the angle measures of a shape. And in doing so, it's also going to preserve the size and the shape. And that's because the distance between points is what's going to create the size, and the angle measure, being the same, is going to keep the shape. Now, the first of the rigid transformations that we're going to look at is translations. Now, there are three different types of rigid transformations. They are the translation, the reflection, the rotation. And with the translation, it is the idea of sliding. So with the transformation, you're moving all the set of points the same distance along lines that are parallel to each other. And the reason these lines are going to be parallel to each other is they're all going to have that same transformation that's being done. We may move all the points, right 3 and down 2. Well, because all of them are going to go right 3 and down 2, they're all going to have that same slope. So that way we guarantee that they're going to be parallel. Now, with the translation, we are specifically looking at two ideas. We want to look at both the horizontal being side to side, and the vertical movement that is up and down that describe the movement to slide the pre-image to its new position, which we'll call the image. So we always go from a pre-image to an image, and with our transformations, with this translation, we want to be able to describe what is both the horizontal and vertical elements to the slide. So for instance, here I've got a transformation. I want to describe what happened to go from one figure to the next. Now I can tell which is the pre-image and which is the image by looking at the points, and I see that one of them is A, B, C, D. So we have quadrilateral up top, A, B, C, D. And then down here we have those apostrophes, which are pronounced primes. So this is figure A prime, B prime, C prime, D prime, and the primes denote the transformation. This is the pre-image, or the original. This is the new image after the transformation. So we want to be able to describe what happened to go from the original quadrilateral to its image. And we're going to look at both the horizontal and vertical components. So what I want to look at is if I go from A to A prime, those corresponding points, I want to look at what happened. So I want to be able to describe both the horizontal and the vertical component. Now with translations, you're going to notice that the orientation of the figure is still the same. This trapezoid is still oriented the same way. A and A prime are still in the upper right, D is going to be on the furthest right, C prime will be at the bottom left, and so on. So let's look at this, and we're going to just basically slide horizontal until we line up, and then go down to see how much it's going to be in this case. So if we look, coming straight up, straight over, if we go 6 units to the right, and then slide down until we find A prime, so straight over, straight down, and count the number of squares here, we had to go down 11 units. So in this transformation, we have slid 6 to the right and down 11. And we're going to notice that all of these are going to have that same movement. So I'm going to go ahead and shade this first one in real quick. And this, I'm going to draw kind of a triangle here, right triangle, just so we can talk about some other properties later. So if we look at this triangle, okay, that's our first one. And we're going to see that all of them are going to have those same movements. So if we look at the next one, let's go to B. For B, straight up would be from here. So if we go over, we're going to see that if we count, again, it's going to be over that same number, in this case, over 6 squares, and then down the same number, which is going to be our 11 squares. So we have that same motion. So at this point, I'm going to go ahead and describe what the transformation is. That we see that xy becomes the coordinate. If it's going to the right, that's getting bigger for the x's. Positive x's are on the right, negative x's on the left. So in this case, if we're going 6 to the right, x is increasing by 6. Whereas the y's, when we go down, the y values are going negative, right? The lower you go in the graph, the negatives on the bottom, positives on the top. So by going down 11, we are subtracting 11 from the y values. And if we were to look at those coordinates, we're going to see that you can take the x value, add 6 to it, and then take the y value, add 11, and that's going to tell you where those new coordinates are going to end up. So in this triangle, I'm going to go ahead and shade this one also. We're going to see that it has the same legs when we form this into a right triangle. And we'll also see that these segments, this pink segment and that green segment, are parallel, right? They have the same slope. They're both going down 11 and right 6. And if we keep doing this for the other ones, we're going to see the same thing. If we go at C, C is also going to go right 6, down 11. So let me go on this one. So if we go right 6, 3, 4, 5, 6, and then down 11, we're going to see that we end up in that same transformation. And if we connect the two segments, C and C prime, the preimage to its corresponding image point, we're going to see that this segment is also parallel to the other two we just did. And then lastly, if we go to our D and look at D prime, we're going to see that again, it's doing the same transformation. Again, it's going right 6 and down 11. All of these have that same transformation of translating right 6 down 11. And we can also see that any of those segments that connected the preimage to its image are going to be parallel to each other. All four of those segments, A to A prime, B to B prime, C to C prime, D to D prime, are going to be parallel to each other. And that's going to get into some of the properties that we're going to be looking at here. So when we connect the segments from its corresponding point of the preimage to the image, there's two things that kind of stand out. First off, all four of those segments are going to be parallel to each other. Now by parallel, that means they have the same slope. And in this case, if we went right 6 down 11, that slope, rise over run, would tell me that we're going down 11 and 6 to the right. So that slope is going to be negative 11, 6 for all four of those. Down 11, right 6, down 11, right 6, down 11, right 6, and again down 11, right 6. All of those segments have that same slope. Now the other thing that's going to stand out is all four of those segments are going to have the same length. Now slope does not prove length. Instead, to find a diagonal length, you need to talk Pythagorean theorem. And by the Pythagorean theorem, that is, if we look at the right triangles I drew here, and that's actually why I drew them in, you're going to see that all of them have the same corresponding legs. Right 6, length of 11 going down, right 6, length of 11 going down, right 6, length of 11 down. So by Pythagorean theorem, all four of those triangles have the same legs of 6 and 11. And when you solve for that hypotenuse, d squared equals 6 squared plus 11 squared, all four of them are going to give you the same length. So when we start talking about translations, some of the properties that need to come out is if you connect the preimage to the image, you're going to see that all those segments that you do that with are going to be parallel and have the same length. Now let's try another example here. Let's take one where they gave us a description of the translation. xy becomes the point x plus 9, y minus 2, and we're going to take our triangle ABC and we're going to draw its image using this translation. Once we have it, we're then going to list out what those coordinates are. So take a moment, and which way are we moving? If I was to say xy becomes x plus 9, y minus 2, the x plus 9 would tell me that we are going to the positive side of x. X is growing by 9, which means we are going right 9. So when we do this translate, we're going to move each point and in this case, right 9 units. And then because y is getting smaller by 2, this tells us we are also going down 2 units. So again, this first element is telling us our horizontal move, and the second piece tells us what the vertical translation will be. In this case, right 9 down 2 units. So that's what we're going to do now. We're going to take our coordinates, and we're going to go ahead and we're going to apply this translation to all 3 vertices. So let's start with A. We are going right 9 units. So from A, we're going to go right 9 units. I'm just going to count off 9 units. So this would be 1, 2, 3, 4, 5, 6, 7, 8, 9. So I've gone 9 units to the right, and then I'm going to slide it down 2 points. So that's going to be our translation of right 9 down 2. And then we're going to find that new coordinate. This is what we're going to call A prime. Now A prime, if we look at from the origin, is 1, 2, 3, 4 to the right, and up 1, 2, 3, 4, 5, 6. That new coordinate is the coordinate 4, 6. Okay, go ahead and try the other two. I want you to pause the video and work it out and see what you get. I'm going to go ahead and connect my segment here real quick while I'm waiting. So go ahead, like I said, do a B prime, C prime, find out where those are going to be, and then resume the video when you're ready, and let's check your answers. I'll give you a moment. All right, hopefully you've done this with the other two, so let's check it. If we go to B prime is going to go right 9 down 2. 3, 4, 5, 6, 7, 8, 9. It's gone right 9 units. And then we go down our 2 units. And this is the new B prime. B prime from the origin is right 2 up 1. So that new coordinate is 2, 1. I'll go ahead and connect that one up. And again, we're going to see that that green segment that I drew a moment ago and this new segment are going to be parallel to each other. They have the same slope, and they're also going to be part of right triangles that have the same legs, which means those hypotenuse are going to be congruent also. And we got one more. Let's go ahead and find out where C prime ends up. C prime is going to move 9 to the right. And down 2 units. And that's going to be our C prime. Okay. C prime, if we look at it, is going to be right 7 up 3. So that new coordinate is going to be 7, 3. Okay, so let me go and draw on my triangle now after I shade this one in. So this one I'm going to do in a different color. So let's do that. So let's just take a look real quick. Look at these segments. We can see all of 3 of them are going to be parallel. All 3 of them are going down to right 9, so they all have a negative 2/9 slope. They're all going to be the same length by Pythagorean Theorem because all 3 triangles have the same legs of 2 and 9. So when we connect the figure in, last thing, triangle A prime, B prime, C prime, this is the transformation of the original figure, ABC. So this is the new image. All right, well, thank you for watching this video.